All right, good evening, everyone. This is Cathexis with another episode of Science vs. Scientism with Quantum Racer. Tonight is a special presentation, and it's actually going to be our season finale. And what we're going to talk about is Dr. Mary Schweitzer and the Atheist Roundtable that she did over on Mr. Steve McRae's esteemed channel. So we're going to be playing the video and working in some factual information that they seem to be leaving out. So if it's going to fall in line with everything that we've been going over, for the past 12 episodes, and, we really appreciate the support that we've gotten. We've gotten a great response from this, and we've got a lot more coming down the road. We are going to be finishing the season off currently with this, and this will be going up just after the fact. We're making this right now, and it won't be live, of course, but then we will be working on some new projects for the future. Probably be down for about a month or two, maybe 3 at most, and then we'll come up with some new things. But how you doing tonight, John?
Doing fine, sir.
Well, good, good. I say we get right into it because we got quite a bit to stomp. So
All
what
right,
I'll be
sir.
doing, I'll go ahead and play the audio for you. Just let me know when you need that, and then we will go from there.
All right. Well, Dr. Mary Schweitzer, a paleontologist at North Carolina State University, she's famous for finding soft tissue in a T-Rex dug up by Jack Horner, which was Mary's advisor in Hell Creek, Montana. And the character Alan Grant, the one in Jurassic Park, was modeled after Jack Horner, who consulted on all the Jurassic Park series movies. So for background, you can see the story here. They did one on 60 Minutes, and just type that into the search engine and you're good to go to pull right up. So Mary decides to show up for a Q&A on the clown show, Steve McRae's The Great Debate Community, as if for a let's bash young Earth creationist love-in. So this isn't a personal attack on this woman. Her discovery opened the tsunamic floodgates on soft tissue. However, she volunteered to speak out on the show, so if she wants to play lumberjack, she's going to have to handle her side of the law. So go ahead, let's roll this.
All right, here we go.
Okay, we are live. It's January 26th. It's 8 a.m. Pacific Standard Time, and we have as a special guest today, Dr. Mary Schweitzer. Most of us are quite familiar with her work. I've communicated with her in the last couple of days to get her to come on for about an hour so we can have a Q&A section. I have about 10 people in here. Other people are welcome. I sent out invites specifically to people. If you didn't get one specifically, it's just an oversight. But if you'd like to join us, please message me on Facebook, Twitter, or G+, and I'll see about getting the link. And Fiona will be taking questions from the live feed. But anyways, morning, Dr. Schweitzer.
Morning.
Thank you very much for joining us. This is a huge thing for my channel and the Great Debate community because so many people have been wanting to ask you specifically some questions in regards to your work and get it directly from you rather than secondhand sources.
Sure.
So what we're going to do is I'm actually just going to have like I said, a Q&A type session. I know Jay wants to start it off with a couple, 1 or 2 preliminary questions, if that's okay, and just kind of dive right into it.
Okay.
Jay?
There we go. Yeah, I just had a little trouble unmuting myself, unpredictable these things can be. Well, good morning, Dr. Schweitzer. I'm very glad to hear you here. One of the things I wanted to ask you is that having a problem with Felis interruptus here. Ready, go. Sorry about that. Cats, when you first, one of the things we heard from Ray is when you first made your discovery of soft tissue that you were mistreated and you were threatened and you feared for your career. And that big meeting, Jack Horner, demanded that you disprove what you found. So what I'd like you to do is to address that. And, what did happen? How were you treated? Did you fear for your career? Was Jack Horner a big meaty? And could you explain how science works and that you're supposed to disprove stuff?
That's too funny. Okay, so No, I never feared for my career because at that point in time I didn't really have one. The first molecular stuff we did, I was a graduate student. And, you know, I will say that one of the best pieces of advice I ever got for my career did come from Jack, and he said, prove to me they're not. It changes how you do science, it changes how you conduct science, and it points out the value of alternative hypotheses. So, when we first found those little round red things in the bones of Tyrannosaurus rex, when I went to him, finally was found enough courage to go up to my major advisor and say, we have these things, you know, so they were the right size, they were the right shape, they contained iron, and they were localized to the blood vessels of this animal. Those are the only things I knew, and I went to him and I showed him. Plus, they seem to have nuclei of some sort, some kind of difference between the inside and the outside of these little red bodies, which, if they were dinosaurian red blood cells, they would have to have a nucleus. So,
All right, that's the first stop. If you'd like to jump in.
So those little round red things with nuclei that contain Fe inside pliable blood vessels in dino bone. I wonder what those are. A mystery. But you sure know how old these bones are without a doubt, right? Continue.
This is what I showed him, and he said, so what do you think they are? And I said, well, they're in the right size, right shape, right whatever, but they can't be red blood cells. And he said, well, why not? And I said, well, because everyone knows they don't persist over this length of time. And he said, so prove to me they're not.
So, you've just been introduced to a textbook preconceived confirmation cognitive bias in the face of prima facie ground squirrel level obviousness. Why? Because it goes against her a priori adherence to the millions and billions of years fairy tale. Continue.
And what that does is it takes my own personal bias out of, well, reduces my own personal bias because I'm trying to disprove my favorite idea. And so rather than trying to prove something in spite of the facts, you try to disprove using data and only data. And if you can't do it, it still stands. That's the thing I think a lot of people don't understand is that it is the role of a scientist to disprove, not to prove. If you're doing
so, it's the role of a scientist to disprove rather than prove. Well, no, and you're merely appealing to half the story. You attempt to reject or falsify the null hypothesis, the default, which if done systematically, ipso facto confirms the alternative hypothesis. If you can't confirm the alternative hypothesis, then the null hypothesis stands. Furthermore, you're not a scientist, love. I'll show you. Please post one viable formal scientific hypothesis in the entire history of paleontology, or show science without scientific hypotheses.
doing science correctly, you are never going to prove anything. That's the job of mathematicians.
If you're doing science correctly, you are never going to prove anything anyway. That's the job of mathematicians. So we can't prove anything in physics and biochemistry, the physical. We can only prove the immaterial, mathematics. So these aren't proven unless it is hindered purposely. In nature, heat flows from hot to cold always. Energy concentrated to dispersed always. High gas pressure to low gas pressure always. Nature or natural law cannot create or destroy matter or energy. Vitamin C deficiency in humans results in scurvy. Protein secondary structure is the result of primary structure and hydrogen bonding. Insulin deficiency in type 1 diabetics results in ketoacidosis. Information is always sourced by intelligent agency, without exception. Life only comes from life. Only the existence of the which path information collapses the wave function. The laws of physics and chemistry contain no symbolic logic functions. Wrong-handed stereoisomers destroy DNA, RNA, and protein secondary structure. DNA transcription, translation, replication. Glycolysis, Krebs cycle, electron transport chain, gluconeogenesis, flagellum, cilia, etc., etc. and bicycles are all in total irreducibly complex. I mean, I could go on for months. So you're saying we're just not sure? But 2 minus 4 equals -2 is proved. Right? Continue.
Yeah.
There is always additional data out there waiting to be discovered that could disprove your hypothesis. If you're doing science correctly, that has to be acknowledged in all your work, in my opinion.
Well, thank you, and I hope that will clear things up for some people. That, you know, you weren't given a hair shirt.
It's not the only threat I ever got, or the only times I ever felt threatened or whatever, were actually from emails I got from young Earth creationists.
So I'm a young Earth creationist. Have I ever cyber threatened you? Can you show us these emails? Just a couple. Continue.
When Jack Warner when he wanted to disprove your work, as you were saying, basically, he's by getting evidence for your hypothesis that it.
What hypothesis was that, Steve? We missed it. And the only way you get evidence for your hypothesis, whatever that is by experiment, testing it. Where's that? Continue.
Find out if it's correct or not. You're actually giving evidence that what you're suggesting was a preservation mechanism could be the actual case, would it not be?
Mm-hmm. Yes.
So, please post the formal scientific hypothesis for our evaluation. Did you observe a preservation mechanism? Isn't the first step of the scientific method observe a phenomenon? It's not conjure a phenomenon. What phenomenon did you observe? Did the soft tissue tell you it was preserved? What if, and I'm just spitballing here, that the soft tissue is young, a few thousand years at best, and it's your fairy tale cognitive bias of millions of years that's erroneous? And again, how in the world can you even formulate a viable scientific hypothesis, preservation mechanism, since you skipped the first step of the scientific method and you don't have a time machine? What's the independent variable in your hypothesis to test your prediction, your dependent variable? Is it your imagination? As alluded to previously, according to Niels Bohr, an actual scientist, no phenomenon is a phenomenon unless it is an observed phenomenon. All you're observing is after the fact concrete nouns. Soft tissue, pliable blood vessels, little round red thingies, osteocytes, etc. Not phenomena. They are merely whats and ises. Scientific hypotheses, real ones, elucidate the hows and the whys of the what of the phenomena you observe. You didn't observe any phenomenon just yet. This entire exercise is an argument from complete ignorance fallacy, guised under the term science, to conjure up a just so story begging the question fallacy number 2, the preservation mechanism, so the precious a priori adherence to the mother fairy tale begging the question fallacy number 1, billions of years just so story can remain intact. In summary, argument from ignorance fallacy, 2 begging the question fallacies, and a non-existent scientific hypothesis. Continue.
Did you have a follow-up, Jade?
Oh yeah, well, personally, I wanted to ask you a question going back to your paper on was it heme compounds and
That's a long time ago.
Well, I'm not going to ask. I was going to say I'm not going to ask anything like really specific because I know you've done a lot of stuff, and I'm sure it'd be pretty easy to bring up some little picayune point from a paper, and then you didn't remember it.
No, well, we've learned a lot since that paper, for sure. I mean,
I know.
Science built on itself. So, a lot of that stuff, we can either support or not support with newer data.
So science built on itself, right? Well, that's a reification fallacy. Science isn't an entity or a result. It's merely a method of inquiry, the scientific method. From Michael Crichton, from his testimony in front of the U.S. Senate Committee for Environment and Public Works in 2005. Science is nothing more than a method of inquiry. There isn't in itself, because methods don't have selves, and it builds nothing. We're just a little over 5 minutes in, and you're well on your way to celebrating a sizable chunk of the logical fallacy catalog. So a lot of this stuff, support or not support with newer data. So that means the initial data could have been wrong, correct? So science is merely a never-ending just-so story, bending, weaving, shape-shifting, all ad hoc hypothesis-like, which, by the way, is a quintessential tenet of pseudoscience, all the way to the end. Is there ever an end? Like maybe, and I'm just spitballing again, a scientific theory. Continue.
Dr. Schweitzer, can we have a brief description, basically, of some of your work, some of your papers? I guess on some of the people in the live feed, just kind of wanted a very tertiary, brief history of some of your publications.
What exactly do you want to know? I'm not sure how to answer that.
The question from the live chat, and I'll read it out for you. It's from Trevor Lunn. Before we get to PhD level discussion, could Dr. Schweitzer give us plebs a brief lay version of her discoveries? Not all the audience are scientists. So a brief lay person description of your findings.
Sure. So basically, when the first dinosaur bones were being found in the late 1700s, early 1800s, that's not the first time they were found, mind you, but it's kind of when real paleontology began, sort of, kind of, with approaching these questions with scientific rigor, or what passed for it at that time. But since that time, when we found dinosaur bones, you had reactions. Dinosaur bones are rocks. Dinosaur bones have been completely altered. Dinosaur bones, are not anything we need to pay attention. Somebody planted dinosaur bones in the ground. But eventually, all those things were disproved. And especially when we began to look at dinosaur bones in the microscope, the scientific community realized that bone is bone. We're not altered, some of them, to the degree that people were assuming. So when I came onto the scene, I was an older student of Jack's. I didn't start my PhD until I was 36. So when I started my research project, I was working to prepare a Tyrannosaurus Rex that Jack had just brought back from kill. And I noticed some things. I had a really, really sensitive nose, which can be the bane of my existence. But when I was preparing this dinosaur, it had an odor. And at the time I was teaching human cadaver labs. And it smelled like one particular cadaver we had in the lab that had died of cancer. And the cancer drugs he had been taking interacted with the embalming fluid to give it a very sweet odor. That's the first thing that came to my mind. So I noticed that, and then I noticed that this bone, the internal parts of the Tyrannosaurus Rex bone, looked just like modern horse. I mean, there was no extra mineralization. It looked like a horse that died about 10 years ago and sat out on the prairie. And
so, and there you have it, folks. This is the rub, the coup de grace. It's the full Monty, the woolly T-Rex in the room. You don't say. Thank you. Maybe now all the pretenders will finally realize what they're arguing, but I doubt it, and my doubts will be evidenced here in a few minutes. The most prima facie truth on the matter of soft tissue, the evolutionist, whatever that is, and the long age brigade just can't seem to wrap their minds around. You ready? The bones with the soft tissue are not fossilized. Let me say that again. The bones with soft tissue are not fossilized. Apparently, this gem is and always has been lost on all the love-in pretender crowd. You see, I'm speaking from years of firsthand experience with this. Nobody has ever told the love-ins this prima facie ground squirrel level truth. Probably because the scientific community, whoever or wherever they are, just assumed that their readers could fog a mirror. You see, the pretenders think that the bones that contain soft tissue are completely fossilized, permineralized, and that all you have to do is to treat them with acid, and these soft, pliable tissue structures just poof it back into existence. It's really scary that they even have to be told, but even when they're told explicitly, straight from the horse's mouth, they still can't reconcile it. Like here and now. You think I'm joking? Just stay tuned. We have a few short ends to tie together first.
All right.
Continue.
I started thinking, well, if it looks this way, maybe there's some tiny remnants of something original there that we can learn more about the animal. And so I was trying to figure out how to do this, and I made this this slide, I guess, and we saw these little round red things. And that's when Jack said, Mary, this is too big for a master's degree. I want you to switch to a PhD. And so that's what I did. And that's when he said, prove to me they're not. And it changed everything. It's like use data to disprove what you think they are. And in the process, I couldn't. I still can't. I don't know what those red things are because I don't have the data to say.
So an enigma wrapped in a riddle. You just don't know what those little round red things are in those pliable blood vessels. From you and Jack Horner in Proceedings of the National Academy of Sciences in 1997. The production of antibodies specific for hemoglobin in 2 rats injected with trabecular extract is striking evidence for the presence of hemoglobin-derived peptides in the bone extract. That the antisera did not react with the snake hemoglobin shows that the reactivity is specific. When considered as a whole, the results support the hypothesis that heme prosthetic groups and hemoglobin fragments were preserved in the tissues of the late Cretaceous dinosaur skeleton. That's very interesting. And by the way, the last part, the late Cretaceous, that's a begging the question fallacy. You have yet to scientifically validate it. But I digress. Even Wiki says, Mary Schweitzer is a paleontologist at North Carolina State University who is known for leading the groups that discovered the remains of blood cells in dinosaur fossils and later discovered soft tissue remains in the T-Rex specimen, as well as evidence that the specimen was a pregnant female when she died. And here's the sources for that. But the big one I want to concentrate on here for a second is Kate Wong's article in Scientific American in 2012. Kate says, it seemed utterly impossible organic remains were not supposed to survive the fossilization process. Still got that wrong. But test after test indicated that the spherical structures were indeed red blood cells from a 67 million year old T-Rex. So like I said, what fossils? It was bone, for goodness sakes. But you, Mary, obviously read this article because you emailed Kate Wong to update it. And it was on October 20th, 2012. But you didn't cry foul with Kate's comment were indeed red blood cells. You just wanted to clarify the antibody reactions with the bird osteocytes. Here, let's pull it up. So this is Kate Wong's article right here about your finds right here. This is where she said that they were red blood cells, indeed red blood cells right here. But down here further at the end of the article, here's the update. Mary Schweitzer emailed me to clarify a point that did not come across in her talk. And those were antibodies with bird osteocytes. So you must have read this. I'm trying to figure out why you didn't go back and square that away. So, are the little round red thingies containing Fe nuclei and soft pliable blood vessels red blood cells or UFEOs? Those are unidentified iron-containing objects. Which one? Or none? Continue.
But we've moved on since then, and we've looked at other bone. We've used more and more increasingly complex methods to study this bone. And what we found is that there seems to be pieces of protein that can only come from vertebrates, and it can only come from something that is not a mammal. And we've been able to show this using antibodies, which are complexes that you produce. When you get a cold, you have an antibody against the cold virus, so you can get better. We capitalize on the immune system of animals to make antibodies against protein, and we use them on our dinosaurs. If they bind, and you do all your controls correctly, you can say with pretty strong confidence that these 3 and 4 amino acid epitopes of the original protein are there. And so we've used paleoimmunology for a long time now with a lot of different specimens. And most recently, one of my former graduate students and my current postdoc have been building upon the idea that you can actually sequence these proteins. And that's when they become really usable and you can ask different questions. And so the protein sequence is kind of like the letters in a word. Change one letter, you change the word. And so we can actually track, looking at the letters of the proteins we recover, to see how closely they are aligned with birds or with crocodiles or with turtles or with humans. And that gives us a whole bunch more information as well. So we've been able to look at functions of these organisms, functions of their tissues, when certain unique novelties first arose, and begin to ask really cool biological questions with the tools of molecular biology. Kind of exciting to me.
And what was the finding on what actually did allow for the collagen to be lasting for so many years, and that the bonds weren't cleaved in that amount of time between
With collagen, I think the mechanisms of preservation are really different depending upon the tissue type. So with collagen, for example, it has this really unique advantage in that it is tightly complex to mineral. And mineral, it has a great stabilizing effect on biomolecules. So in the process of bone formation, the collagen is laid down by the bone cells, and then it is subsequently mineralized, and that mineral collagen association gives stability to both. So I think that's part of it. And if you have mineralized protein, as in collagen, part of the way that collagen degrades is it expands. And if it's completely housed in bone, it can't. The second thing is that the bacterial enzymes can't access the protein if it's safely persistent in bone mineral or surrounded by bone mineral. And so you have a lot of different things coming together that contribute to the preservation of collagen.
Really, there's a lot of different things coming together. Well, during a Live Science interview, you said it's very, 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 not just very, controversial, because most people have gone on record saying there's an absolute time limit to anything that's protein or DNA. In 2011, UK archaeologists and experts on bone collagen decay wrote that it will take between 200,000 years and 700,000 years at 10 degrees Celsius for levels of collagen to fall to 1% in an optimal burial environment. And this is really interesting from Bartazzo from Nature Communications. These two statements are both from the same paper. Statement number 1. In particular, it has long been accepted that protein molecules decay in relatively short periods of time and cannot be preserved for longer than 4 million years. Therefore, even in cases where organic material is preserved, it is generally accepted that only parts of the original proteins are preserved and that the full tertiary or quaternary structure has been lost. Compare that with if collagen is completely degraded, this banding is no longer seen due to the loss of quaternary structure of the protein. Observation of approximately 67 nanometer banding in the fiber structures of the fossilized samples here is very exciting, as it is consistent with a preservation of the ultrastructure of the putative collagen fibers over a time period of 75 million years. Well, there's a problem here, right? He's saying down here, 75 million years, no problem. But wait a second, no longer than 4 million years. I guess this is all hinged and dependent upon what this means. It has long been accepted and generally accepted. Don't know what that means. Probably need to clarify that. Continue.
This is actually the structural component of collagen and allowed it to last as long. Well, one of the conditions.
One of the conditions, yeah. And then collagen is a real robust molecule. It's kind of hangs out for a long time under normal circumstances. So in bone, it's orders of magnitude more lasting.
Did that get your questions, Esther Jade?
Oh, sorry, I had muted myself. Yeah, that got that my second question answered. And the third thing I was just simply going to ask you about, which I think Steve might narrow, is to tell us a little something about osteocytes. The osteocytes you found.
My favorite cell.
Oh, good.
Osteocytes are unique to vertebrates. So if you look at fungus or a moss or a worm or a crab, they don't have osteocytes because they don't have bone. So the origin of osteocytes actually goes all the way back to the early Paleozoic when we had the first bone fish show up. Osteocytes look the same whether it's in a Paleozoic fish or in a human. Their structure is constrained by their function. So their job as osteoblasts is to secrete collagen, and that collagen becomes mineralized. And then when that happens, the cells can't move around freely. They become entrapped in the matrix they secrete, but they still have to function. They have to get rid of waste, they have to get in nutrients. And so that cell changes its shape to send out all kinds of little legs from the body. And those legs form kind of like a bucket brigade. So you have osteocytes close to the vascular channels in bone and dip these little legs into blood vessels to get out the nutrients, so to speak. And then they pass the nutrients on up the chain until it's time for the next one to operate. So they are constrained because of what they function like and where they are to have these little legs. All osteocytes have elongate bodies with bunches of little legs coming off of them. So when we demineralized our T-Rex, that's one of the first things we saw.
So when she says demineralize the T-Rex, she's talking about demineralizing the bone, not fossil, that house these structures. A common way to do that is EDTA. It's a weak acid. It's a decalcifying agent. You can check your sodas, soaps, and detergents for that. Continue.
And my technician at the time said, oh my gosh, I think it's a contaminant. There seems to be a bug in there. And I looked at it and immediately, no, that's an osteocyte. And that has never, soft tissue, transparent, flexible osteocytes have never been considered to be possible. Although there was some hints as early as 1966 from a Polish colleague that we might indeed find these someday. So if you have the cell and it's a vertebrate cell, you have a nucleus and you should have potentially DNA. But with osteocytes, they're so unique that osteocytes actually produce some proteins that only osteocytes of birds produce, for example. And we were able to show.
Could I just ask a question, please? You gave a date there. I missed the date of your Polish colleague.
1966. Roman philosophy.
66. Okay, thank you. Sorry about that interruption.
No worries.
Now you were saying before that you said something about antibodies that were specifically binding to the DNA and the osteocytes.
Yes.
Could you talk about that a little bit more and maybe explain to the less biological among us the difference between an osteoblast, osteoclast, and maybe an osteocyte, so people kind of know a little bit what their regards to.
Yes. An osteoblast is a fat little cell that sits on the edges of tissue, chunks out collagen, and as it begins to mature, it moves deeper into the tissue and becomes constrained by the mineral, like I said, and becomes an osteocyte. So an osteocyte is a grown-up osteoblast. And then an osteoclast is not even in the same cell lineage, but it is named for its function. It's the bone eater. Osteo means bone, clast means to eat. So these are cells that are actually part of the immune system that eat bone. And you need that. So for example, if you're a couch potato and you decide that you're going to start lifting weights, your bone has to strengthen to accommodate the added stress. So your osteoblasts go into action and your bone gets thicker and a little bit more dense, which is why exercise is a really good thing for osteoporosis. But suppose that you do something completely different with your bone than you normally do. Your muscles are going to change orientation slightly, and that's where your osteoclasts come in. They have to get rid of the bone that's no longer needed, so the osteoblast can lay it down in the right shape.
I think what we might do later on, if people are interested, if Fiona and Jade want to do it, we might have a little like secondary hangout sometime to explain some of these more biological terms if people are interested. I got to get to Jack because Jack is actually leaving for class here soon, but I know he had a few questions to get in, so I was going to get him real quick. Jack, go ahead and ask your question because I know, like I said, you're on a tight schedule.
Yeah, this is where the real motivation of the show is revealed. They're not so much interested in what Mary found, but more of how they can pick up some tidbits to battle those evil young Earth creationists. Continue.
Oh, okay. All right. Hi, Dr. Is it Schweitzer?
Schweitzer.
Okay. This is a simple question, but it requires a little bit of a background. So it's about your most recent paper, the one that was published 23rd, I think.
Just a couple days ago? Yeah.
Yeah. So a friend of mine here on Google Plus, Young Earth Creationist, he posted the article, or posted a Science magazine article talking about your paper. And the title of the paper was, or title of the article was like 80 million year old fossil confirmed to have collagen, something like that. So I guess his impression from that and the impression that that article gave made it seem like your paper would be like really discussing the age of the fossil a lot, the 80 million years old. And I guess the article wanted to give an eye-catching headline, you know, it sounds nice. And so there's a couple of young Earth creationists who commented on his thread and saying, oh, 80 million years, that's ridiculous, that's crazy, and like laughing at it. And so I decided to look at the paper. I go to Texas A&M, and I can use I can find the paper and have access to it and stuff. So I went and read the paper and didn't see anything about the ages. So I looked at the citations for that, went on a citation hunt to try to find where it talked about the actual dating of it. And through that, I saw that that wasn't really the focus of your paper, and that's not really the focus of any of your papers. Yeah, but that's the impression that sometimes these articles give, is that, you know, so I was wondering, where did you get the dates for the T-Rex and the Brachylophosaurus canadensis fossils? We have a person who's does geology in here too, paleontology, not geology, Bill, right? He was talking about the KT boundary. I've forgotten about that. But I guess, is there any specific papers in the literature or anything you could point to that show the age, the dating of those specific fossils?
Yeah, there are. I don't mention it because it's not my area of expertise. It's well documented, and I don't need to reinvent the wheel. But Greg, I can't remember his last name. If you look at Hell Creek Formation age or Hell Creek Formation dating, Judith River Formation, you'll see the papers, the geology behind why they say what they say. So the Hell Creek is about the last 3 million years of the age of the dinosaurs. It is deposited during a time when the Mesozoic ends and the Cenozoic begins. So it is divided from the later sediments by the KT boundary, which in Montana is spectacularly visible in the parts of the country that we look at. You can go up and put your finger on it. It's kind of cool. So you never, ever, ever find a whole articulated T-Rex above that boundary. Find a lot of other things, but you don't find T-Rexes, which is one of the reasons we say that's when dinosaurs went extinct. But it can be dated in a couple different ways. The most common way for dinosaur-bearing sediments to be dated is what we call relative dating. A relative dating is grounded by absolute dating if you have any kind of volcanic activity. So where I work, there's a lot of mountain building activity at the time of the dinosaurs. So we do have themes of volcanic material and ash that can be dated absolutely. So we use absolute dating to bracket the youngest and oldest potential times for the sediments that bear our fossils. And then we use relative dating techniques within that bracket to figure out exactly where it lies.
So basically what she's saying is they date the fossils by the rock layers they're found in, and they date the rocks by the fossils. That's what she's saying. So from Dr. Niles Eldredge, paleontologist, the lesser half or the co-creator of punctuated equilibrium, the evolutionary, whatever that is, non-change, change fiasco by Stephen Jay Gould and the aforementioned Dr. Eldredge. He has to say, paleontologists cannot operate this way. There is no way simply to look at a fossil and say how old it is unless you know the age of the rocks it comes from. And this poses something of a problem. If we date the rocks by their fossils, how can we then turn around and talk about the patterns of evolutionary change through time in the fossil record? Yes, Dr. Eldredge, the problem is called circular reasoning. From the Concise Geological Timescale in 2008, geological stages are recognized not by their boundaries, but by their content. The rich fossil record remains the main method to distinguish and correlate strata among regions because the morphology of each taxon is the most unambiguous way to assign a relative age. This then is convoluted and parroted to our kids in school. Watch this one, folks. This is Glencoe Biology, page 306 and page 307. Let's start with page 306. Fossils in the lower layers of sedimentary rock are older than those found in the upper layers. Often the layers of the rock can be dated by the types of fossils they contain. So the rocks are dated by the fossils, right? The very next page. Scientists have determined the relative times of appearance and disappearance of many kinds of organisms from the locations of their fossils in the sedimentary rock layers. So the fossils are dated by the rocks. We have ourselves a circular banjo-do-si-do going on here. Continue.
Okay. So you said that the absolute was with the volcanic activity and things like that. What was the relative dating, though?
Well, absolute dating is based upon radiometric decay. So it's physics, it's inviolable, it is one of those laws that's really hard to get around.
Well, the radioactive decay law, as is the case for all physical laws, is consequent. That is, it's contingent upon quantum mechanical laws. From the chair of physics, Professor Shankar at Yale, the laws of physics are always quantum mechanical laws. That is, the following condition must exist, necessary antecedent, before you can appeal to the radioactive decay law. And it's kind of hard to get around. According to Niels Bohr, Werner Heisenberg, Max Born, described by Erwin Schrödinger, then validated repeatedly via thousands of experiments without exception for the past 100 years with the most successful branch of physics in the history of actual science, quantum mechanics, independent of the knowledge of the which path information, or of it existing, particles, that is photons, all elementary particles, atoms, molecules, have no defined properties or location. They exist in a state of a wave function, which is a series of potentialities rather than actual objects. That is, matter doesn't exist as a wave of energy prior to observation, but as a wave of potentialities. Wave functions aren't waves like classical peak troughs. They're potentialities, probabilities. They have no mass energy. You can't give me the frequency or wavelength of a wave function. To put it another way, the wave of a wave function is not a wave in physical space. It's merely an abstract mathematical construct. So matter, rocks, our reality doesn't exist without first a knower or the existence of the which path information. Listen to this closely. From Professor John Wheeler, it begins to look as we ourselves, by our last minute decision, have an influence on what a photon will do when it has already accomplished most of its doing. We have to say that we ourselves have an undeniable part in what we have always called the past. The past is not really the past until it has been registered. Or, to put it another way, the past has no meaning or existence unless it exists as a record in the present. So, unless you can provide the name of the person who originally observed these rocks, date, timestamp, registered, and recorded them, then a chain of continuous observational custody till current times, you must now provide the decay rate for a wave of potentialities. It'll be easier sprouting broccoli from your armpits. Continue.
Stratigraphic dating or relative dating is if you have a layer that only contains clams, for example, and you go up a little bit and you have a layer that only contains trees. And you go up a little bit further and you have a layer that only contains dinosaurs. Then you can say, okay, unless you invoke the reversal of physics, the clams are older than the trees and the trees are older than the dinosaurs. That's relative.
How about if I invoke common sense and logical reasoning? Note, your clams comment above echoes from the Glencoe biology quote we just looked at. Fossils in the lower layers of sedimentary rock are older than those found in the upper layers. You know what this is? This is a formal logical fallacy. It's called denying the antecedent. If P, then Q. Not P, therefore not Q. So, if they're buried together, P, then they both existed together, Q. They're not buried together, not P, therefore they didn't exist together, therefore not Q. And you wonder why the scientific literacy is circling the drain at light speed in the US. Continue.
That makes sense.
Yeah, that clears my question. Or just one more thing for the absolute dating. Do y'all use, I guess, mass spec? For y'all, you wouldn't do that, but the people who are dating that absolutely would use mass spec, I suppose.
That's one of the common methods, yes. Okay. There's all kinds of different ways that you can get at that. And all radiometric dating is not equivalent. So I get a lot of people saying, well, why haven't you done carbon-14?
Yeah, I know that.
You know, there's a reason for that. And so, you know.
Yeah, haha, there is a reason for that. The reason for that is, according to your stories, if they find a speck of C14 in your T-Rex tissue, the jig's up. It's up. Why? The half-life of C14 is 5,730 years. So after 1 million years, there should be no trace of it. Animals only take it in as they breathe and eat and stop once they die. Ergo, if you find C14 in dino soft tissue, collagen, that is supposedly 80 million years old, then the fairy tale millions of years implodes. From the inventor of C14 dating, Dr. Walter Libby. There is no known natural mechanism by which collagen may be altered to yield a false age. Let me translate that. There is no natural mechanism to contaminate collagen with new carbon. Why? Because it's part of biological matrices. Once the animal dies, that's it. If its presence is found in these tissues, then turn out the lights on the fairy tale millions of years. Period. End of fairy tale. It surely doesn't prove the Earth is 6,000 years old. Nothing will either way, but it surely and unequivocally implodes your fairy tale millions of years. That's why when your partner Jack Horner, during a live telephone interview, was offered $25,000 to run the analysis, guess what he did? He ran. No worries. Since then, C14 tests have been done on numerous other soft tissue specimens, and take a wild guess what they found. By the truckloads. It matters not anyway. See quantum mechanics above. Over.
And we wonder why they laughed when that was brought up.
Yep. That's why they were laughing.
Oh yeah. All right, moving on.
I guess you have to be certain that the isotopes you're looking at are appropriate for the questions you were asked.
Right.
It is interesting to note that the rates program that the young creationists had, all of them actually agreed that the isochron dating methods did indicate an old Earth, and that the physics was correct, except that they were trying to find a way to say that decay constants had changed. But they did acknowledge that these dates are accurate within the framework of the science that we know to be the case, as now. So I wanted to point that out.
That bugs me. Why would God try to trick us?
He wouldn't. You and they are accomplishing that feat all by yourselves. See Hanlon's razor. Continue.
That's a question we've asked them before.
That's really demeaning. It's like, okay, we're going to give you a brain and we're going to make a world of order, because order is something God's known for. Rational, he's consistent. So we're going to make this world of order, and then, wow, we're going to trick you by saying that all the rules that you can figure out with your brain no longer apply. I don't buy that. God's not the deceiver in this. And I think that young Earth creationists have to be really, really careful when they sit there and try to manipulate the data to support their worldview. That is not science.
I think everybody in this hangout agrees with that 100%. I've noticed there's two camps.
So God's not the deceiver in this. Agreed. And honestly, I don't think you are either. This is a clear case of Hanlon's razor. That is, don't attribute to malice, which can be explained by ignorance. You also said young Earth creationists have to be really, really careful when they sit there and try to manipulate the data to support their worldview. That is not science. Are you charging me, a young Earth creationist, with manipulating the data? And data comes from experiments. I have yet to hear anything in the remote vicinity of one just yet. Continue.
Then I'm going to get to hog tie real quick. I think there's two camps, though. One of the types of creationists that we deal with, they're the ones that don't recognize the data. They say the data doesn't indicate old Earth, and the other ones that say that yes, the data does, but they're trying to come up with science that kind of changes the laws of physics as we know it to try to explain the data. So there are two different types of creationists out there that do.
Oh, there's more than two. Yes.
I'm being very, very broad in umbrella.
Yeah, if I wanted to mention, Steve, Kevin Haller pointed it out too. It's one of my favorite statements is that I don't believe in a trickster God.
Yeah, I agree.
If I wanted to trickster God, I'd go to Loci.
Yeah, I can't imagine a deity that would make all the evidence point to an old Earth, have a consilience across the board of many, many different types of isochron dating methods, and then say, oh, I'm just trying to trick you. That makes no sense to me whatsoever to have a deity like that. But anyways, Hogtie, we want to make it home because I want to fit you in here.
I just want to say goodbye real quick.
I'm sorry, what, Jack?
I just want to say goodbye real quick, and congratulations on the repeat of the collagen experiment, the paper.
It was fun. My postdoc did all the work, so I can't take much credit.
Remember I queried earlier, you think I'm joking? We now get introduced to Hogtie. Thanks. You're a gem in the rough. And listen, there's nothing against Hogtie here. He's merely putting into words what they all believe. Pay somewhat close attention over the next painful, for them, few minutes. Continue.
Yeah, the gentleman that is about to speak coming up, that's his name is Hogtie. So just for the audience, you'll get to know him really quick.
Hi, y'all.
Yeah, the Brachylophosaurus discovery is exciting. It's neat stuff. Unfortunately, I have two questions, and I'm going to have to, if you don't mind, I'm going to drag you in the Wayback Machine here, because what we're faced with online here when we want evidence, we want facts. Well, they're going to the creationists will often throw up a BBC web article that was posted in 2005. Now, apparently, this is based on an interview you had given with Science in Motion, or Science in Action, rather, in 2005.
Remember, probably that was a really bad time for me. So
yeah, well, it's funny how a scientist's footprint can be made by people other than that scientist who's actually doing the investigation. But this is where you had discussed things like you said that there's the appearance of these red blood cells, and as you very clearly described in here, you're saying that you were looking at these things with a microscope, and but you didn't make the declaration, well, look, we found these red blood cells. Well, of course, we're hearing that. Oh yeah, no, they found. I mean, they're saying like viable proteins. They use terms like that, viable proteins, and I think the first question I want to ask, pardon me, has to do with what's meant by fossilization. Because as you read the BBC rewrite up of your interview on Science in Action, it sort of tugs at the layman's understanding or perhaps misunderstanding of what's meant by fossilization. And I'll say it this way, not being a paleontologist, I live fairly close to the Royal Tyrrell Museum, and you can, on your way there, you might see a deer that had dropped dead, and there's bones, right? And you look at it and those are bones. And then when you go to the museum, there are rocks that are bone shaped, and they will tell you, well, those are fossils. So there's a thing that's a fossil and a thing that's a bone.
But they're not rocks. That's a fallacy. They're not rocks at all.
So Mary laughs, then Hogtie laughs, and Mary says, they're not rocks. That's a fallacy. Newsflash, Hogtie. Both Mary and you are laughing at you. P.S. It's not a fallacy. A fallacy denotes a flaw in the reasoning process. This is just plain good old-fashioned ignorance. Continue.
Just slice one up and stick it under your microscope. There isn't a rock on the planet that looks like that.
They don't let me touch them. Everything's under glass in there. Actually, I do have a chance for a tour with the director, which would be kind of interesting. But I guess, can you, what I'm asking here is that regarding this stuff in 2005 and how it was presented to the public, it sounds like that there was this amazing rethinking and revision that happened about the nature of what is meant by the word fossil. Can you maybe help us out a little bit in terms of how the word fossil is used, and whether or not this was sort of an earth-shattering find to find that there's actually, you say there's amino acids, protein segments. What is meant? Help the layman understand here what is meant by fossilization and what is a fossil.
Nobody knows.
See, do you see where he's going here? You see where they're trying to go.
Mm-hmm.
He's going to get his shot group tightened here in a bit, but what's meant by fossilization? Mary's reply, nobody knows. So nobody knows what a fossil is? From Cambridge Dictionary, for a fossil, part of a plant or an animal or its shape that has been preserved in rock or earth for a very long time. Period. That's pretty fair. I mean, we're not talking about flies and amber. We're talking about dino bones. So specifically, permineralization. This occurs when mineral-filled groundwater, mainly calcite, iron, and silica, fill the pores of organic structures and replaces the internal parts with minerals. Petrification is the complete replacement of those organic structures with minerals. Now, the reason why this guy's asking, it's pretty hilarious, because he thinks the bones Mary found were fossilized or completely permineralized. How do I know? Because I dealt with these intellectual aristocrats thousands of times. They're bones, not fossils. She's going to tighten your shot group again here in a minute, although it's not going to sink in. It's a gift that keeps on giving. But first, how on earth could Mary pull soft tissues from completely permineralized bones? Fossils. Do you think when they dissolve, permineralized remains, fossils, then the soft, stretchy body parts poof back into existence? And how on earth can these bones, which are allegedly buried for 80 million years, not be completely permineralized? Continue.
So what I can tell you is that traditionally a fossil is any evidence of past life. So it can be a petrified tree, it can be a microbe entrapped in its own mass that's mineralized, it can be a dinosaur bone, it can be, you name it. If it is, it can be a trackway, it can be a worm print, it can be anything that testifies that life was once there. So that is the meaning of the term fossil. Its co-opted meaning, which never really is discussed, is that when a fossil forms, you got the animal, you got the skin, you got the muscles, you got the guts, you got everything else, all the proteins, all the DNA, all the cells, when it dies. Gradually over time, it becomes buried before or after all those soft tissues degrade, and that determines the state of your fossil. But you know this, if you hold meatloaf too long in your refrigerator, you got the beginnings of degradation right there, and you can see it. So I guess that's where this idea came from, that proteins can't persist. But the idea is when all of the soft tissues and all of the original proteins degrade away, they then get buried, and when they're buried, rocks sitting above it contain minerals that dissolve and then are redeposited in the spaces of the bone, where the bone cells at, where the blood vessels sit, and the bone becomes dense and it becomes hard. So that is kind of what we think of when we think of a fossil, is not a bone turned to rock, but a bone that's been infiltrated with secondary minerals. If you look at the bones of dinosaurs under the microscope, they look just like your bone. They just have a few extra minerals in them in the places where there were spaces.
And there it is, folks, again. Kablooey. But he still hasn't caught on. Continue.
So what it means to be a fossil, it simply is evidence of past life. Poop. We have fossilized poop. That's a fossil. What it means for fossilization is it is a process by which things go from the biosphere, or that part of the world that supports living organisms, to the geosphere, or the rock record. And that can happen in about a billion different ways. And so it depends upon what you mean. And that's about the best I can do. I mean, feathers fossilize differently than bone fossilizes, and that fossilizes differently than skin, and we have all of them in the body. I don't know if that helps any.
It does. It's a great answer, and it helps address this thing we've been arguing about. Is that when they talk about some of your finds, of course, they're referring to the 2005 discussion of the T-Rex. That they're saying, well, this thing wasn't fossilized. Like,
yes, that's right. That's what we're saying. It wasn't. That's what she just told you and been telling you since the beginning of the show. But, and this is getting painful, you're still not catching on yet. Continue.
Like this thing's, they say it's been around for 68 million years, but it hasn't fossilized. And we tell them, well, no, that is a fossil. That's
Here we go again. It's not a fossil, for goodness sakes. And you are all wrong. She just told you again. But it appears no comprende, right? It's all right. Continue.
I mean, the issue in terms of what chemical processes have gone on and minerals filling in spaces and things like that. Well, that's that's the devil's in the details, of course. But so if I can, I think it's a great answer, and it's helpful. I think we'll.
You think it's a great answer and it's helpful? This is tantamount to Jacques de Molay, Grand Master of the Knights Templar, saying, "Thanks, that's a great answer, very helpful," to Pope Clement V when hearing of the orders to burn him alive at the stake. Now she's going to tell you again. Continue.
Some of us will have to we'll retread that in conversations when these guys continue to bring it up, because they always bring up the same old stuff. Yeah. So there's links to my.
In that, like if I show you a 2 medicine formation bone, so this is the equivalent age of our Brachylophosaurus, but it's from a different part of one. You will see that bone completely what's the word I want? Secondarily mineralized. So it's discolored, and it's every single available space is filled with hard mineral. And like I said, nobody really uses the term fossilization correctly, but if you're going to use it in the common vernacular, that bone represents fossilized bone. That's not, I mean, that's inaccurate, but that's what people think of. When they think of fossilized bone, they think of that. And in that sense, and in that sense only, our T-Rex was not. The open spaces in the T-Rex were open spaces. There was no secondary mineralization. It was lacy, it was light, it was unaltered, and I could hold a piece of it in my hand and put it next to the piece of trabecular bone from a horse, and you couldn't tell the difference.
So that, like she said, that bone represents fossilized bone. Here's the juxtaposition. In that sense, our T-Rex was not. It was lacy, light, and unaltered. I could hold a piece of it in my hand, put it against a bone from a horse, and you couldn't tell the difference. Do you get it now? Nope. Here you go again. It's still not sinking in. Listen closely to this next exchange. Go.
So in one sense, it wasn't fossilized in the classic sense of being completely remineralized the way that a lot of bone is. It was weird.
Just really depending on how people are going to be using the word.
Exactly. And that's one of the things I drive my students crazy on is words count. Words are important. Your words carefully.
But it wasn't like huge chunks of actual bone that didn't have any kind of permeabilization or anything between the bone matrix or anything like that.
Correct. Well, define huge.
Several centimeters.
It was.
Was it several centimeters?
Yeah, absolutely.
That's something that I wasn't aware of.
But it wasn't like, this is what Hogtie said, but it wasn't like huge chunks of actual bone that didn't have any kind of permineralization or anything between the bone matrices or anything like that, correct? Mary Schweitzer, well defined huge. Hogtie, several centimeters, haha. Mary Schweitzer, it was. Hogtie, several centimeters? Mary Schweitzer, yeah, absolutely. Finally, touchdown. Hogtie, that is something I wasn't aware of. Yep, that's quite obvious. You sure are aware now, aren't you? So for everything sacred and holy, please ask her, how on earth can these bones, which are buried for 80 million years, not be completely permineralized? Continue.
Well, in some of my earlier papers, I've actually got pictures of it. The 1997 JVP paper, we show that exactly.
Does that answer your question, Octavio?
It does, and it kind of nicely kind of leads into the second one, because I sort of, I guess what I'm wondering about, and I kind of think I know the answer to this one, but I want to hear you say it out loud. When these things come up, and you know that people are still discussing this thing from 2005, and now with this recent Brachiosaurus, they're going to start up on, sorry, Brachylophosaurus, I got the wrong creature there. They're now going to start speculating about that stuff. You hear about these things, and you even get contacted directly by them. My question is as a scientist, why do you not invest a bunch of time in the public eye and setting up Google Hangouts with creationists and setting them straight?
Well, Hogtie, she's not a scientist for one. You then say, why do you not invest a bunch of time in the public eye and setting up Google Hangouts with creationists and setting them straight? Well, sir, she'd get her hat handed to her just like you just got yours handed to you. And good thing she was in this hangout to set you straight. Did you thank her for that? But I doubt that it'll make a dent. I'll have to spend 3 War and Peace posts, as usual, explaining why soft tissue doesn't come from fossils for the next 10 years, just like the last 10 years. It's quite mind-numbing. Continue.
That's a softball. There you go.
My job is to do the research, to gather data, to present the evidence for a hypothesis. I am a scientist. When I wear my science hat, I don't have beliefs. I have only data. It's very boring. Data can only do two things. It can either support or fail to support, or disprove. I guess that's three.
And I think that's the truth.
No, experiment supports or fails to support. Big difference. Continue.
Well, this is something we hear quite a bit. Is it when a creationist puts up a blog somewhere, does a YouTube video? Over time, there'll be this response of like one of the things we've been discussing in this community is you might be surely be aware of this, that human chromosome number 2 is likely a result of a fusion of 2 ancient ape chromosomes, and
human chromosome 2 fusion, right? My goodness. The 90s called, they want their argument back. This is a begging the question fallacy. Where'd you get chromosomes, DNA, naturally, spontaneously, from its respective building blocks, which is physically and chemically impossible? Then for an encore, where'd the information come from? Then show the experiment that validates this fairy tale fusion nitwittery. Why? Well, the final arbiter of truth in science is experiment. From Professor Shankar from Yale, the only way things change in physics is experiments. Everything is based on experiment. That's the only way we change our mind. From Max Planck, experiment is the only means of knowledge at our disposal. Everything else is poetry, imagination. So go ahead. Till then, keep your fairy tale imaginations to yourself. Capiche? Furthermore, if you think this soft tissue train wreck was taken out back to the woodshed and given what for, go ahead and wheel out the disheveled just so fairy tale story of evolution, and I'll club it so ferociously that the incoherent oblivion will blush. Oh, and define fossilized soft tissue. Continue.
There are PhD holding people that work at ICR who write about this stuff, and one of the things that's thrown in our face quite a bit is, well, gee, the scientific community hasn't responded to it. They can't respond to these things, right? They're just like, they're so baffled by this brilliant writing by the folks at ICR that they're all hiding under the blankets, unable to address these things. And I suspect, having practiced in that area, that there's a different reason why scientists are unable to address these concerns that come up about their work. And I mean, you went with not my job. I was expecting you to say there just literally aren't enough hours in a day. Like you're under a lot of pressure for career development, and you have obligations to your institution and your students. And the idea of doing what we do, sit in Google Hangouts and discuss these things, we really appreciate your time today for sure. But is this going to be how science is dealt with by arguing with individual creationists with their web pages?
I can't. I'm sorry, but I can't. It's a waste of my time. It's a waste of my energy. And I think it does not honor God to go down that road and follow that lineage. It's not important. If these guys would take...
Well, please post book, chapter, and verse for us. I want to see that one. And love. The show that you're having fellowship with right now are 99.999% atheists. Have you ever read this? Ephesians 5:11. And have no fellowship with the unfruitful works of darkness, but rather reprove them. That is, expose them, Mary, to the light. Continue.
Half the energy that they spend trying to prove that the world is young and use it to change the world around them. Feed the hungry, take care of the kids, get the cats off the street. Anything. That our world would be so much better, but they wouldn't.
How about if you guys take half the energy you use to keep telling us your fairy tale pseudoscience yarns about how old the earth is, then you devote it to herding cats. Something productive. Continue.
Waste so much time and energy and effort on disproving that the world is old. It's not a salvation issue. Get over it.
That is such a wonderful.
It's not a salvation issue. Get over it. Really? Well, if there were millions and billions of years with death, disease, thorns, fossils, the clear result of sin, see the Holy Bible, before Adam and Eve, the fall, see Genesis 3:17 through 21, then why the need for a kinsman redeemer? That's Jesus Christ. The whole of the doctrine of salvation is disannulled. This scenario. Yeah, Adam's saying it's very good, just like God said. Everything's real good on a foundation of pain, death, killing, disease, thorns, struggle, suffering for millions of years. Preposterous and blasphemous. You make him a liar, and then you have him sacrificing himself for his kinsmen, trilobites. And yes, it's really that bad. Continue.
Full answer.
Yeah, and you touched on one of my pet peeves too, is that most of the people who are invested in that enterprise, and that is convincing people that the earth is quite young, are not at all invested in spreading the gospel message.
Yeah.
And I mean, I'm not all that interested in that. I'm not really that motivated to see that the gospel message is spread effectively, but I'm more invested in seeing the scientific enterprise proceed. And I think that having, and exactly what you were just saying, I mean, you say, we don't have time, it's not your job, I think that dealing with people who aren't listening anyway doesn't advance the scientific enterprise. So I really like your attitude to the whole thing.
I just, I get really frustrated sometimes because there's so many things that are so much more important than this. And it's like they're stubbing their toe on a toenail. And there's so many things that energy could be used to a greater good. And I think, again, tripping on this stupid little issue does not in any way honor God. What are they trying to do?
So, book, chapter, and verse again, please. And you said, what are they trying to do? We're establishing truth by proving all things. 1 Thessalonians, prove all things. Hold fast that which is good. That's what we're trying to do.
And
continue.
I just like to say that is one of the most important verses I've ever seen in any holy book. And I don't come from exactly a Christian perspective. As we all know, I'm very neutral, but that one absolutely stands out. It's probably one of the most important ones I've ever seen. So
sure,
just want to add that. Here we go.
It bugs me. It really bugs me because it's a huge weight.
Do you think they're putting their own personal ideological beliefs ahead of of anything else? That they want this to be true so much that they're unwilling to actually examine things intellectually speaking.
Yeah,
it's a bias, and the science community has plenty of biases, believe me. So, and I can think of many in my own field, including the bias that original molecules don't persist in fossils. So everybody has bias. We're human, and the biases arise out of our own experience. So,
oh, we know about their bias, especially when they're not scientists. And can you please give us the address of the scientific community we keep hearing about? We have some comments. And you said, including the bias that original molecules don't persist in fossils. Well, number one, we're not talking about fossils. We're talking about bones, remember? My word. So we're biased to think that soft tissue can't last for 80 million years? That's not a bias, love. It's called groundswell level awareness. And a law of physics, decay, increasing entropy. The second law of thermodynamics. Continue.
Bias can be changed with data.
Bias, if you are an honest scientist, bias is always changed with data.
If you're an honest scientist, bias is always changed with data. No, it's only changed if and when you shelve a priori adherences to fairy tales, and then only by experiment, if you're honest. Continue.
But you asked the hard question. And see, for me, when people say, don't you get upset when your scientific community says this kind of stuff about you? And I'm like, no, that is their job. And, there's always scientists out there, trust me, who are a lot smarter than me, who think about things that I don't think about. And maybe I missed something. That's their job. And so they keep me honest. They keep me disciplined. They keep me hardworking. But in the end, if my data is good enough, if my data are rigorous enough, if my data are repeatable enough, they can have their minds changed. And that is science. It isn't faith. That's science.
Absolutely.
When I wear my science hat.
And that is science. It isn't faith. Yep. That's a false dichotomy fallacy. From Max Planck, where is science going? Anybody who has been seriously engaged in scientific work of any kind realizes that over the entrance to the gates of the temple of science are written the words, "Ye must have faith." It is a quality which the scientist cannot dispense with. So either you're right and Max Planck is wrong, and or you're equivocating fallacy with the word faith. Guess where my bet's going? All in. Continue.
And I don't have beliefs. I have only data.
Yeah, I think the people we're talking about just really don't understand the battleground that you're describing. It's a great enterprise. And I have about 11 more questions, but I got to be respectful of other people in the room and Dr. Schweitzer's time. So I'm going to yield.
But we get about 2 more people in real quick.
I'm going to have to get off in about 5 minutes. I got a whole bunch of stuff waiting on me. So.
Okay. I have to make a decision between Bill and Paul. Paul, actually, Bill, I'm going to have to wait on you. Paul has been waiting a lot longer. I know Paul has videos out. So Paul, you had some very specific questions to ask Mary. Can you go ahead and?
Sure, I'll try and keep them quick. So I was recently in a Young Earth seminar where your research was used to support claims that working blood vessels, fresh blood cells, and intact DNA had been found in dinosaur cells or dinosaur fossils. Is that a fair characterization of your research?
It's wrong on all counts.
So Paul says working blood vessels, fresh blood cells, and intact DNA. Now, working, come on, they're not working blood cells or blood vessels. I mean, these things are dead. Fresh, well, that depends. I mean, obviously, they're not fresh. It depends on what you mean by fresh. And intact DNA. And she said it's wrong on all counts. So, really? So, we have this from you, from the Proceedings of the Royal Society B again, as arguably the most labile and easily degraded of these structures we observe, the presence of soft vessels is enigmatic. These, the ones you showed on 60 Minutes, not so much of the little red thingies, it's these blood vessels. See, that's what caught my attention. I mean, like you said, this is pretty enigmatic because they shouldn't be there, right?
Mm-hmm.
Number 2, we already discussed the red blood cells, or the UEFOs, train wreck, the unidentified iron-containing objects. And now we get to DNA. So from you again, from Bone in 2012, these data support the presence of non-microbial DNA in these dinosaur cells. But I understand, though, you didn't actually say that it was dino DNA, but no worries, though. We got Alan Toft from Proceedings of Royal Society B in December 2012. However, even under the best preservation conditions at -5 degrees Celsius, our model predicts that no intact bonds, average length 1 base pair, will remain in the DNA strand after 6.8 million years. This displays the extreme improbability of being able to amplify 174 base pair fragment from an 80 to 85 million year old Cretaceous bone. All right, that's an because obviously they were looking at these guys back in 1994, Woodward and Weyand, and they said from their study, the lack of amplification with other primer sets is consistent with the sample being free of contaminating contemporary DNA. Amplification with the noted primer set produced 174 base pair fragment. So these guys are trying to debunk these guys. From this study, from the abstract, DNA was extracted from 80 million year old bone fragments found in the strata of Upper Cretaceous Blackhawk Formation in the roof of an underground coal mine in eastern Utah. This DNA was used as the template in a polymerase chain reaction, PCR, that amplified and sequenced a portion of the gene encoding mitochondrial cytochrome B. These sequences differ from all other cytochrome B sequences investigated, including those in the GenBank and European Molecular Biology Laboratory databases. That is, the sample was not contaminated by anything known on Earth, basically. So that's the end of the video. It would soon end itself. But I want to get back to this alleged preservation mechanism. That, oh, by the way, that was brought up previously. See, I was expecting this to be the main part of the discussion, and I kept on waiting and waiting and waiting, and they just never got back to it.
Well, the pretenders kind of, those things are lost on them usually.
Like I said, it was mentioned, like I said briefly, way back in the beginning, but it's this one right here. It's from Mary Schweitzer. It's a role for iron and oxygen chemistry in preserving soft tissues, cells, and molecules from deep time from the proceedings of the Royal Society B. Basically, what they're going to do here is they're going to conjure up a witch's brew and place some vessels in it, then imply this has some role with soft tissue preservation from deep time. And you see from the study, right, this is how they get around, you know, not committing. They have commitment issues. A role for iron and oxygen chemistry. So they didn't say that it was, you know, the cause, because they can't. And we'll get to that here in a few minutes. But I've had this thrown in my face so many times. Of course, they only throw it in my face once. After that, they know better. They receive the wrath of Khan. You're going to see that here in a couple minutes. But it's not Mary's fault. I mean, she's not telling these people to throw this in our faces like this. But clearly, this study is implying quite heavily what's going on here. So talk about pure baloney. Number one, the materials and methods section of this paper is not a part of the paper. They're in the electronic supplementary material. This raised an eyebrow since it's not normal protocol at all. But I chased it down. Let's wait one for that. So, transmission electron microscopy, see figure 1A, C, and E, we're going to get to that here in a minute, was performed on the same T-Rex femur, not fossilized, remember, that she discovered 8 years prior. Question: was the bone in the same conditions in your lab for 8 years that they were in Hell Creek, Montana? Could you briefly describe the climate and the soil characteristics of Hell Creek, Montana, then juxtapose that with your lab climate? The Hell Creek Formation soil is very moist and high in Fe and silica. Iron loves water and likes to form iron oxide rust in the presence of oxygen. We would like to see the thin section tissues of the femur in 2005 TEM'd and see if the iron filaments are absorbed to the vessel walls at that time. Why? Well, in the lab for 8 years, the femur was most likely stored in a dry environment. Therefore, the iron would migrate to the closest H2O moist source. That is the soft tissue while the bone dried out. The soil in Hell Creek, Montana is even richer in silica than iron. And that leads us back to the question again. Why are these bones not silicified in total, since they've been buried in it for 80 million years? So number three, blood clots readily in ruptured or torn tissues. See the blood clotting cascade. Number four, upon death from trauma, blood will drain from the arteries into the veins and pull at the lowest part of the limb or body. See livor mortis. The T-Rex femur here was disarticulated, separated from the body. In figures 1C and E, you can see the iron filaments pulling only on one side, not even absorbed on some on the vessel. That is, the iron filaments are highly localized and have not infiltrated the tissue. See figure 1AC and more remarkable E. Can iron particles reach across huge swaths of tissue to preserve them? They imply that iron acts like formaldehyde or formalin, which cross-links the proteins so they don't degrade. The formalin is a 7 angstrom size molecule at 0.7 nanometers, while the iron particles are 100 nanometers, and they're supposed to perform the same function? Let's take a look at this. is Mary's study, the role of iron and oxygen chemistry, right? Here's the photos that we were talking about, or the figures. Let's concentrate here on A, C, and E. We don't care about these guys over here, so Brachylophosaurus and ostrich. These A, C, and E are the T-Rex. So, as you can see right here, the iron filaments are adsorbed to the vessel walls right here. Well, that's fine, but we want to see this figure is from 2013. We want to see the 2005 T-Rex figure and see where these iron particles are. That's what we want to see. You can figure, in figure C here, you can see the iron particles. We're going to see them closer here in a second. They are localized. They're localized in these batches right here. And they point them out for you. They're even better right here. You can see that they're localized right in here. So what's happening? Are these iron particles, cross-linking these proteins? How are they doing that? By telekinesis? Looks like they're localized to me. I'm not a certified microscopist, but that looks kind of concentrated. So let's go back. So now we get to the really hilarious part. Remember, I was talking about that materials and methods section. See, at university, I remember vividly looking at my schedule and seeing evaluating research printed on there. Then depression set in. Number one, because I knew it was going to be boring. And number two, I had bigger fish to fry. As it turned out, it was the funnest course I ever took. And it was absolutely invaluable with both my academic and professional career. And continues to pay dividends. And just for your information, it was a rare exception rather than the rule that any study passed muster. I can remember the class laughing out loud on many occasions. And these weren't the B movies either. These were studies from the premier scientific journals on the planet. So, in the main technique, and I should charge you guys for this, I had to back up the Brinks truck to get this information. So let's go up, show you a little trick. Save you a lot of time. So basically, what Mary studied here, just like with any study, this is the headline. Typical to newspaper headlines, what do you do with it? Well, you just, yeah, right, sure. You take the abstract and you skim through it just to get a feel of what's going on in this study. That's all you need. Just get a small feel, say, hey, the money shot is this guy right here. That's where you go. Why? Because this is the rate limiting step. You find any picadillos in here, you can summarily toss the whole thing right out because it's garbage. You don't have to waste your time going through. Some of these are War and Peace novels. But that's where you go. This is the guy, right? But in Mary's study, it raised an eyebrow. Guess what? It's not here. I mean, what's up with that? I'm definitely going to go track it down. So, and I did. This is the chicken and ostrich blood, like I was talking about before.
Mm-hmm.
Are these scientists or witches? Where's the frog legs and the bat pee? See, an anticoagulant, number one, an anticoagulant was used to prep the chicken and the ostrich blood. Question, are there anticoagulants circulating through the soil in Hell Creek, Montana? And why did they use an anticoagulant? Number two, both blood solutions were washed in isotonic saline. Question, is there isotonic saline bath solutions floating through the soil in Hell Creek, Montana? Number three, high-speed centrifuges were used to spin down the blood to remove serum, platelets, white blood cells, and tissue factors, and others, and concentrate the red blood cells. Question, are there high-speed centrifuges circulating through the soil in Hell Creek, Montana? I suppose removing serum, platelets, white blood cells, tissue factors, etc., are variables that are routinely removed post-mortem in animals that perish catastrophically and are buried for 80 million years. Number four, the red blood cells were washed again in isotonic saline. Question, is there reusable isotonic saline solutions floating through the soil in Hell Creek, Montana? Number 5, hemoglobin was then extracted by incubating cells in a phosphate buffer on ice to lyse the cells. Question, guess. The solution was centrifuged again 4 times to precipitate then remove cell debris and concentrate hemoglobin. Question, round and round we go, literally. Number 7, this solution was then filtered through glass wool 3 times to remove red blood cell ghost remnants. Question, have you ever been in a Turkish prison? Number 8, this solution was then subjected to ultrafiltration using 3kD Amicon ultracentrifugal filters to concentrate and desalt the hemoglobin and exchange buffer to E-pure water, which was brought to the same volume as the original blood volume, respectively. Question, guess what my question is? And there's a hint. E-pure water, isn't it? Then we're not done. Hemoglobin or control solutions were degassed by ultrasonification under argon gas continually for 5 hours to remove oxygen. For the hemoglobin and the phosphate buffered saline deoxy conditions, to maintain the deoxy condition, vessels in either the hemoglobin or water were placed in 2 milliliter tubes and sealed chambers and purged with argon for at least 5 minutes once daily. Yes, and all this seems reasonable and natural. These conditions perfectly match those in Hell Creek, Montana, over 80 million years, in situ, endogenous dino soft tissue bones in Hell Creek, Montana. Then they placed the ostrich vessels. These vessels are 5 months post-mortem in the purified heme solution in the lab for 2 years at room temperature and said, voila, iron acts like formaldehyde, rust preservation. Then they compared the tissues swimming in their purified heme solution to the phosphate buffered solution and sterile distilled water solution and said, wow, in our test model, incubation in hemoglobin increased ostrich vessel stability more than 240-fold, or more than 24,000 over control conditions. So this equals blood preservation in an 80 million year old dino bones buried in Hell Creek, Montana? Define a non sequitur fallacy from the Black Lagoon. From your paper, here we show data from both fossil and extant organic material to support the hypothesis that iron contributes to preservation of soft tissues and molecules. Really, you know, if you were in 5th grade general science, right, and the teacher came up to you and said, listen, I'm just going to give you one chance. I want you to use the first 3 steps of the scientific method and then formulate a formal scientific hypothesis to pass my class. If you provided this, you're taking 5th grade general science again. Number 1, you didn't observe a phenomenon like we talked about before. See the first step of the scientific method. Therefore, you don't have a valid, relevant hypothesis, which ipso facto invalidates the entire inquiry. Number 2, the T-Rex wasn't fossilized. It was bone. Remember? Number 3, the post hoc hypothesis actually is, given 5 months post-mortem ostrich vessels, immersing them in a purified heme solution that was artificially manipulated to the nth degree to even produce, contributes to the preservation of extant soft tissues. Yeah. What's the null hypothesis that was rejected or falsified? I'd like to see that one. This has about as much to do with soft tissue preservation in 80 million year old dino bones as Aunt Jenny's late summer tomato haul in Tupelo, Mississippi had to do with the main length of Alexander the Great's horse. I mean, you have to be a special kind of ignoramus to even entertain this buffoonery. But there's a special category to reduce yourself to this 3rd grade science experiment, and I use that phrase as loosely as possible, in a flailing attempt to pass this off as containing even a sliver of legitimacy. I suppose this explains separating the materials and methods section of the paper, the most important part, from the study. So get ready, coming to a store and a mortuary near you after the patent rush, replacing cryogenic freezing, float in a vat of chicken blood. Number 2, new at the funeral home. Formaldehyde is hazardous. Iron is green. Embalming in blood. Put your loved ones in ostrich blood. Number 3, food preservation. Blood packaging. Yeah, it's mind-numbing absurdity. I suppose that discussing the iron-generated free hydroxyl radicals, the Fenton reaction, would be beating a dead horse at this point. Free radical tissue preservation. Yeah, you trying to put the fruit and vegetable industry and GNC out of business? This associated fiasco is tantamount to attributing King Tut's body preservation by appealing to the filling of the sarcophagus with brown recluse spiders. Just in case you were truant with last week's presentation, the dating game, and this pseudoscience, let's touch on a few highlights briefly. Any 5th grade general science graduate knows, prima facie, that all dating methods are outside the purview of the scientific method. For goodness sakes. You have no independent variable, so as to form a valid scientific hypothesis, to test and validate your prediction. Science. You see, independent variables are the input, the cause, that is changed, that is manipulated and varied by the scientist, so as to measure or validate the output, the effect. Dependent variables, your prediction. Independent variables are the sine qua non, indispensable as it were, to scientific hypothesis construction. Then ipso facto experiments. So, can you please elaborate? How on earth can you change the input and test your prediction on a past event without a time machine? You're in a simple category error. The scientific method is used to validate cause and effect relationship. It's non sequitur to use it to extrapolate age of anything. It's tantamount to using a framing square to calculate the GNP of the Netherlands, for crying out loud. Ergo, a better question. Given the immutable fact that dating is outside the purview of the scientific method and can never be validated, why on earth are these long ages pushed ad nauseum, mainly by pseudoscientists, then stage 5 clung to with a kung fu death grip, then blindly parroted by the masses as fact, and all challengers ridiculed endlessly for even bringing the topic up? Sounds like propaganda to me. It's mind-numbing. You've already gotten up close and personal with radioactive decay and quantum mechanics regarding the past. Your last port in storm is light years. I pummeled that a few weeks ago, right here. Speed of light in the CMB. What's next? Ice cores and tree rings? Go ahead. Make my day. Let's wrap it up. This is the world record holder for soft tissue preservation. 550 million years old, this beard worm. From the Journal of Paleontology. The Sabellidite's organic body is preserved without permineralization. Minerals have not replicated any part of the soft tissue, and the carbonaceous material of the wall is primary, preserving the original layering of the wall, its texture, and fabrics. Now, if you believe in your religion, materialism, realism, and atheism, which has been scientifically falsified, by the way, see episode 2, that this worm is 550 million years old, I have a bridge for sale. By the way, oy vey. Thanks for your ear. Have a nice day.
Well done, John. You know, we're going to get this directly over to Mr. McCrae and Dr. Schweitzer as soon as possible. And I really hope that they take the time to review this and have a proper response.
I don't know.
What do you think? Do you think they will?
I don't know. There is no. I don't know how you can respond.
Well,
I really don't. Maybe call me some names, but I'm used to that. I can brush those off, by the way.
so you think the carbon-14 issue that they laughed about, they said, oh, well, we definitely didn't do that. Do you think it's off the table for them because of the foregone conclusion, the assumption of age? Would you say that?
Yeah, I'm not going to attempt to speculate on what their motives are because, listen, most think that ink, paper, and glue molecules can author technical instruction manuals and blueprints. So I can't form any opinion on their motive for stuff, but I don't know what to say. I mean, obvious they don't want to have it done. It's already been done. There's many studies out there. Listen, these guys got a hold of these things, and then
It's been found. Yeah.
Yeah, but remember, and I don't really care about it. I really don't, because quantum mechanics just implodes this whole radiometric decay deal. It implodes it right at its base.
Well,
So,
I think that's a little bit beyond some of these pretenders out here, though. So
no, I don't think it is. I really don't, because this
we can
is
only
clear. Yeah. I hope this is pretty clear. I mean, if you get into studying this stuff, I mean, quantum mechanics is nearly 100 years old now. There's no excuse. No excuse.
Yeah, yeah. Well, I do think the carbon-14 situation really is pretty powerful because we know what would happen the moment that they do it. We know, and I think that
it's already been done.
Of course it is, but the laugh that they gave when they brought that up,
sure,
it was telling. Moments like that, between individuals, you find those, and it's usually very telling of why. So
yeah, that's what. Well, they didn't explain it. They just laughed. No one explained the reason why. Mary said there's a reason for that, and then she went into, they have to be particular isotopes. Yeah, I got it right. Yeah, but C4, well, you got soft tissue. Collagen has carbon in it. Let's do it. Just send it in there. Let's go. Let's do it. And that telephone interview with Jack a few years ago. It's been a while since I listened to it, but I remember it was pretty dismissive. Like, I don't know. He was bored with the phone call, and this guy was telling him, "We'll give you 20." I think they started out with 20,000.
Mm-hmm.
And then the guy goes, "Well, heck with it won't." Like he was going to, pitch in the next 5,000. He even told Jack, he goes, "Listen, even if you have money left over, you could just keep it. We don't care, and we'll put that down in the contract." Right?
Wow.
He never got back with him. He said, "Yeah, I'll get back." Never got back with him. So there you go.
Yeah, I think it's very telling because as you pointed out earlier, in especially in our series when we went through and tried to show what real science is, what scientism is, what we're dealing with here is a just so story.
Yeah.
About the age of the Earth, and it is a combination of just observational situations. These fields of study who are observing something and then insisting.
It's based on their fairy tale a priori assumption. You can even watch that B-Rex. I would suggest to everyone, go and watch that 60-minute special on B-Rex. There's one moment in there where Mary's looking at Leslie Stahl and she goes, "Can you believe that? 80 million year old soft tissue." It never even occurred to her, obviously, that, well, maybe that soft tissue is not 80 million years old. Just maybe. That's
what I think. I think, as you brought up Hanlon's razor earlier, I think that is the case. I think that it's literally foregone conclusions on top of foregone conclusions and a misinterpretation of what science really means at its core through university, through all of these processes. And you have this authority structure, you have this belief system of materialism. It is that dogma, materialism, rationalism, naturalism that has brought us to this point where we are just insisting that it can't be this, so we have to say it's this. And then they come up with all of the stories necessary for that to occur, which includes the billions and billions of years, which includes this creation story themselves, even going to the Big Bang. It's all linked.
Connected. It's all connected. It's everything's connected. Yeah.
Absolutely. And this has been well established through just over the past, I would say, 250, maybe 300 years. It wasn't in that direction quite in the beginning when it was just naturalism around Francis Bacon's time and whatnot. But there's definitely been a shift, over the past 300 years to find an answer outside of accepting a possibility that this might be a creation of some kind. That seems to be the motivation.
Listen, it all comes down to ground squirrel level reasoning and knowing what science actually is. Science is nothing more than its method. Like he said, it's merely a method of inquiry. See, these guys, like we've been preaching for the past 13, 14 episodes, they're masquerading under the term science when they're not even using it. They're not using the method.
Yeah.
And they're telling people, well, this is this and this way is that. They're priests. That's what they are. They're basically priests.
High priests of scientism.
Yeah. If you want to make a claim, hey, there's no problem. I got no problem with it. You got a claim? No problem. Show me the experiment. Show me the scientific method. It should be easy. It should take you less than 5, if you had to write it out, 5 minutes. Max.
Mm-hmm.
I don't, if you don't have the experiment, if you didn't do the experiment, no problem. Go find it. There's plenty of databases out there. Start punching in key terms, pull up the experiment that supports what you're trying to say. You don't have to do it yourself. I wouldn't expect that. But go research it. What are your beliefs based on?
Yeah. And that's what they are. They are beliefs. And the quicker humanity starts to realize how much of what they think is real and true are actually beliefs and belief systems, the better we're going to be. You look at, especially with that atheist crew, that rational materialist, the naturalist, somebody who adores modern science, and they basically worship that authority structure. And that's essentially what I call the scientism crowd, is people who are operating out of belief systems and thinking that it's scientific fact.
Yeah.
And the funny thing is, science prides itself on always being able to change. Like, if we're wrong, we'll figure it out, and we're going to fix it.
That's not science.
What I'm saying is, though, as soon as you point out a bunch of wrong things about their belief system, they insist that you're stupid or wrong or ignorant or whatever, when they're just a walking contradiction in that regard. These fields that, especially this one, paleontology, but all the other fields that we've listed in the previous, cosmology, astronomy, these are people just making observations, and they have no way to control their variables.
Yeah,
so
exactly.
It's just an observational field, I guess you can call. But they masquerade as scientists.
Yep, that's exactly what they do. Real science doesn't change because it's based on experiment. The only way that changes if your experimental design is a train wreck. That's the only way it changes. The only thing that does really change are just so stories. They start piling up on each other. That's what changes.
And this is what we have. It's so clear that when you analyze, especially the past 150, 200 years, what we've gotten is this story piled on from all different of these, in these non-real science fields, like cosmology, connecting with paleontology, connecting with the just so story that biology wishes to put forward. Now, I'm not saying biology. Biology is a real science if you're able to make your tests and such. I'm not discrediting that. What I'm saying is the evolution story, and then through the cosmology that provides the billion years, and then paleontology, which fits right into there. This little story that they've concocted has got holes all over it.
Oh, yeah.
And that's essentially what we're pointing out. people need to wake up to this and realize that it's just a belief system. It's just a story. It's another creation story. And they'll
It's a
sit there
religion.
and it is.
Tell them what it is. Tell them
It's
exactly what it is.
absolutely.
Those
Absolutely.
things, when you don't have evidence for your claims and you believe it, that's religion. That's the definition of it. So,
Absolutely. And a lot of these followers, these scientism followers, especially who talk all these terrible things against believers of some type of religion, they use faith as some type of bad word. The funny thing is, they are the ones with the most faith in the institutions and the white coats. The people who are, at that top of the pyramid with whatever field, they just, oh, well, the scientists said, and they're more credentialed, so why should I listen to you? It is this accepted authority structure, which is dangerous. You have C.S. Lewis, Aldous Huxley, even Orwell was warning us about scientism coming on, this possible, even, I won't go so far with it right now, but scientism is this real phenomenon where we have this authoritative belief structure. And the quicker humanity realizes this and we all kind of start working to change it, the better. Hence the reason why I'm blessed to have you here and have these conversations, because you do bring the knowledge, you bring the tangible information that everybody can see. So yeah, I appreciate you so much, John. It's been a great presentation. Is there anything else you'd like to add to this one?
I don't think I need to add anything to this one.
Yeah. Well, we're gonna get it over there to them. I'll go immediately and post it. But I want to let everybody know, like I said earlier, we're going to be taking a couple months off. I've got some other projects in the works right now, but John and I are going to come back for perhaps a different project, perhaps something expanded onto this. We haven't figured it out quite yet, but definitely look out for it. We'll keep everybody updated. And I really want to tell everybody thank you for all the support that we've gotten. We get a lot of live viewers, and then we also get around 1,000, 1,500 views currently. Right now, we haven't really even been promoting it hard. So, that means a lot. And so thank you. Subscribe, like, pass it around to everybody. We're also working on a revised issue of the entire series visually. We have this awesome friend from Russia who has called us, who is working on a project right now that is going to add some visual stimuli to the whole process. So that's coming here really soon, and yeah, it's just great. We've gotten such a great response. Seriously, John, thank you so much for the whole series. I've learned a dramatic amount of information in just 13 weeks.
You're very welcome, sir.
Yeah, I can't thank you enough. So everybody have a wonderful evening. Thank you for the support, and we'll see you guys soon. Take care, everyone.